Hello everyone, I'm Xuan Shun, and today I will be presenting to you my EMF assignment about quadratic functions and graphs and how they are affected by different inputs. Now, the general form of a quadratic functions is expressed as ax squared plus bx plus c, where b and c are the varying inputs. I'm now using b and c as 6 and 9. For question 1, they asked me to input values for y equals to x squared plus bx plus c. So I'll substitute my b and c and the corresponding x value inside, and I'll get all these values accordingly. Now for the graph here. The blue curve represents y equals to x squared, while the orange curve represents y equals to x squared plus bx plus c. Now, if I were to change the b and c values to 4 and 6, let's say, look, the table values and the graph will change accordingly. Let me change the value of b and c again to 6 and 5. The table of values and the graph will still change accordingly. And the blue curve doesn't change because it's not dependent on the varying inputs b and c. For the next question here, I'm asked to find the numerical discriminant for the equation right here. I need to apply the discriminant formula, which is b squared minus 4ac. Then I'm able to come up with this answer since I already know the values for a, b, and c. For x1 and x2, I need to apply the quadratic formula negative b plus minus square root b squared minus 4ac over 2a. And I can find my x1 and x2. Now, my numerical discriminant is positive, that's why I have two answers. For question 4, I'm given a completed square form of y right here. The general form of a completed square is a bracket x plus x minus h squared plus k. If my b is a positive value and my c is 0, the graph will shift to the left. But if my b is negative, let's say negative 5, the graph will shift to the right. Therefore, I can determine that b over 2 is how much the graph shifts to the left or right. For c minus b squared over 4, it is the same as k in the general form of the completed square. So I can determine that it is how much the graph shifts above or below, and it's the same as the change in minimum point of the graph. Now, if you take a look at this, I change the b to 0 and I put c to a positive value, let's say. The graph will shift upward, so as the minimum point of the graph. But if I change my c to a negative value, the graph will shift downwards, as well as its minimum point. For the last question, different discriminant values will give you different solutions. If the discriminant value is more than 0, let's say I change my b to 5 and I change my c to 4, the graph will intersect the x-axis twice, therefore it will have two real solutions. But if the discriminant value is less than 0, for example, negative 3 and 7, the graph will have no real solution as it does not intersect the x-axis, and instead it will have two complex solutions. Finally, if the discriminant is equal to 0, you will only have one real solution, as there's only one intersection with x-axis. That's all for my presentation. Thank you for listening.